Morning, my awesome Algebra 2 students. This is Miss F. I will not be in school today, but I would like you to learn SLT 21, which is inverse variation. We are introducing rational function today in the form of inverse variation. You may need your calculator today. I will assign you the calculator number tomorrow. In the meantime, you can just get one calculator and make sure you put it back where you got it at before the end of the period. Okay? So let's read the problem. Chelsea is celebrating her birthday. Hannah wants to buy Chelsea a gift, but the gift costs $360. Hannah cannot afford to pay for this on her own, so she thinks about asking some friends to join in and share the cost. Number one question, how much would each person spend if there were two people dividing the cost of the gift? So the cost of the gift is $360. There were two people sharing the gift. So each person has to contribute $180, correct? That's per person. How much would each person spend if there were three people dividing the cost of the gift? So if there were three people, you might want to do this with me, okay? Make sure you got your paper on from the algebra 2 bin. So 360 divided by 3, so that gives us $120 per person. You might need to try this also. How about 5 people? So then we have to divide $360 by 5. I think you can do this on your own. How about 10? How about 100? So 10 will be, so $360 divided by 10 is $36. How about 100? That'll be a lot, but a lot of people. But let's do it anyway. So that will just be $3.60 per person. Don't you wish you have 100 friends to contribute for your birthday? Right? Okay, so that is number 1. So review your answers for me before we work on number 2. Number 2, determine the function that could be used to model the amount each person would spend depending on the number of people contributing the gift. When we say function, it's like a model. So this is like a model here. When they say a model, it's like an equation. You can use it for every value of x. That's why it's called a function or a model or an equation. All right. So I think for number 2, I can come up with a table of values where x represents the number of people contributing. And then my y value will be the cost per person. Okay? So if you're the only one buying the gift, you have to spend $360. If there are 2 of you, basically I'm summarizing what values we got a while ago. 180 degrees. Oh, $180, sorry. I'm thinking of my pre-calculus. So 3, we have 3, $120. For 5, $72. For 10, $36. For 100, $3.60. So if X number of people here, then all we have to do is, so here, how did we get 180 here? We divided it by 2. 360 divided by 3. 360 divided by 5. So therefore, this one is 360 divided by 360 divided by x. So therefore, our function is y equals 360 divided by x, or f of x equals 360 divided by x. Okay? So that is our function. That is our answer for number 2. So what we just get here is actually a rational function in the form of inverse variation. Why do they call it inverse variation? If you'll take a look at the number of people here, as the number of people increases, what's happening with the amount or cost? The amount decreases, right? So if one is up, the other is down. Inverse. Now this is in form of a table. Let's take a look at it in form of the graph. So at this point, I'd like you to plot the points, okay? So you're given the graph. So if you will start with 1, then you should have the 360 here, okay? So 1, 360. So your graph should look like this. Your graph should look like this. Why? Because one person will spend 360. If there are 2, that person will spend $180, okay? If there were 3 about here, they'll spend $120. There are 5. So if I'll give you an assessment, I need to see at least 3 points accurately plotted on the graph. Question is, do I need to, wait, let me finish the 10. 10 will be $36. Do I need to connect these points? Is this discrete or continuous? Something to think about. Actually, I should not connect the points because we do not have like 1.5%, but just for you to see the trend of the graph. These are actually discrete variable. Number of people is discrete variable, not continuous. I should not connect the points, but for you to see the pattern, the trend, okay? So what can you say about the graph? The graph is decreasing from left to right, of course. As the number of people increases, the cost per person decreases, okay? So as the number of people increases, the amount each person needs to contribute decreases. This is what we call inverse variation. So what do you notice about the graph? I already asked you that a while ago. So it's decreasing. We call this, you notice, it's not, it will keep decreasing, but it will not really get to 0. There is no like a 0 amount, okay? A zero number of yeah. And also I'm thinking about like 0 number of people here. So we call this vertical asymptote for a rational. This is rational function. When we say rational function, it's a function that can be written as a fraction, like in this form. Okay? So this is the horizontal asymptote. Asymptote would mean it's like a line that the graph approaches but will never touch it. So let's take a look at another example here before you work on your own. We're almost done, and then I'll let you do your own classwork. This time we're going a little bit algebraic. Consider the following statement. The product of 2 real numbers is 1. When we say product, we're multiplying. See how I wrote it? X times y. We don't know these 2 real numbers, but we know we're multiplying them. X times y is equal to 1. Okay? Because it says the product. Now we are going to rewrite this equation. So initially, your homework for tonight is similar to this, the second paper. So you have homework even if I'm not here. I want you to do the one that has, your homework is the product of 2 real numbers is equal to 12. So we are starting with multiplying. Rewrite the equation so that it's solved for y. What do we mean by that? We're going to isolate y. How do we do that? We're going to undo multiplying. How do we undo multiplying? We're dividing. So y will be equal to 1 over x. Now this is actually the parent function for a rational function, okay? This is like the basic graph for a rational function. So we will complete the table using the, you can complete the table using, if you want, you can put this in your calculator. Put it in y equals, and then you check the table of values by doing second graph. Okay? Or you can do it by hand. So if you're going to do it by hand, so this is 1 over x. I want you to include -1 and 1, okay? So if this is -1, for example, 1 divided by -1, so that's -1. So on the graph, you'll see there is 1, -1, -1. See this point here? Okay? So I'll do another one. We're almost done here. Okay? I'll do another one. So if I'll do 1, if you take a look at this one here. If I do 1 divided by x will be 1 divided by 1, which is 1, 1. So I'll plot 1, 1. You can see all this in the table of values. So and then how about 2? If I do 2, look at 2. 1 over x is 1 over 2, which is 0.5. So on the graph, you see 2.5. How do I do that? 2 on the x, 0.5 here. And this is actually an odd function here, so you can just, you will see that it's symmetric to the origin. Okay? So let me do another one. What about 0? How come it's undefined? It's undefined because I cannot divide a number by 0. So what does that tell me? At x equals 0, it's a vertical asymptote, okay? And also, there's another vertical asymptote here, which is the y equals 0. So now let's take a look at use the graph to write the characteristics, okay? The domain from left to right would be all real numbers except the vertical asymptote, which is x equals 0. Left to right, we can use any x value for domain except the 0. For the range, we can get y values from negative to positive, but not 0. The end behaviors, as x approaches positive infinity, as it goes to the right, you notice it's decreasing. It's decreasing, but it's not going to touch 0. It approaches y equals 0. From to the left, as x approaches negative infinity, as x goes smaller, I know it's increasing, but it will not touch the 0. So what happens as x approaches 0? Let's see from the right. As it approaches 0, from the left. As it approaches 0, y values go down. From the right, as it approaches 0, y values go up. Okay? So I'm going to finish up with the definition of asymptotes. Or not, asymptote is a line that the graph approaches to, but they're not going to touch it. So for this example, horizontal asymptote is y equals 0, vertical asymptote is x equals 0. So y equals 1 over x is an odd function because it's symmetric to the origin. I'm going to stop from here, and I need you to work on one practice, which is the -1, this one, and the other side is your homework. Okay? Thank you, and see you tomorrow. Bye-bye.